Introduction. The Canadair Regional Jet Environmental Control System, or ECS, provides temperature-regulated bleed air for ventilating the flight deck and passenger cabin. Conditioned and/or recirculated air is used to cool the avionics equipment and to ventilate the cargo bay. Ram Air provides emergency ventilation of the flight deck and passenger cabin should it be required. Pressurization of the aircraft is accomplished by regulating the outflow of air from the pressurized hull of the fuselage. The ECS uses air from the 10th stage bleed air manifold. On the ground, the bleed air manifold can be pressurized by either or both engines. The auxiliary power unit. An external air cart. In flight, the pneumatic air source to operate the ECS could be both engines. The APU at altitudes less than 15,000 feet. Controls and indications. The controls for the environmental control system include air conditioning control panel, cabin press control panel, bleed air control panel, fan selector panel. Indications for the ECS are presented on the primary and status page and the ECS synoptic page. Air conditioning system introduction. High pressure, high temperature air from the 10th stage bleed manifold is used by the air conditioning system to create a temperature controlled environment within the aircraft. The air conditioning system is controlled from the air conditioning control panel. System indications are presented on the ECS synoptic page and the primary and status pages. Air conditioning packs. The flight deck and the passenger cabin have two identical but independently operated air conditioning packages, also called packs. The left and right packs are located in the aft equipment bay. The packs are controlled by switch lights located on the air conditioning control panel. Each air conditioning pack consists of the following components: left and right pack shutoff valves, pre-cooler, dual heat exchanger, air cycle machine, dual bypass valve, water separator, ducting. The air conditioning process takes place inside the pack in three separate but related steps. The first step reduces the high temperature of the manifold bleed air. The second removes excessive water from the air prior to flight deck and passenger cabin distribution. The third and final step involves the blending of pack discharge air with hot bleed air that has been allowed to bypass most of the conditioning process. Pack pressure regulation. Pack valves receive high-pressure air from the 10th stage manifold and reduce the high air pressure to the level needed to operate the air conditioning packs. There is one pressure-regulating pack valve associated with each pack. Pack operating pressure is displayed on the ECS synoptic page. The packs operate on two flow rates. Normal flow is used when both packs are operating. High flow is used when only one pack is available. Pack overpressure protection. Built into the pressure regulating valve is an overpressure protection feature. This feature prevents damage to the air conditioning system should the pressure regulation feature of the valve fail. When high pressure is detected downstream of the pack valve, the associated pack valve and the bleed air valve supplying the source air are closed automatically. ICAS indications of the overpressure condition include amber left or right high pressure caution message, white left or right pack off status message, white status message associated with the closing of the shutoff valve. Pack valve start sequence. The pack valves are automatically closed during the engine start sequence. When the start switch light is selected, the pack valves close to shut down the air conditioning. All bleed air is redirected to the air turbine starters for engine starting. When the engine starter disengages, the start valve closes and the pack valves return to their previous positions. Temperature regulation. Temperature regulation is controlled by a temperature controller. The heating and cooling of conditioned air at each pack occurs by blending air taken from 3 different places in the air conditioning process: primary heat exchanger, secondary heat exchanger, pre-cooler. The temperature controlling process is normally automatic, but can be regulated manually by the crew. Automatic temperature control. The air conditioning systems are normally operated in auto. The cockpit and cabin rotary switches located on the air conditioning control panel are used to adjust flight deck and passenger cabin temperatures. Left and right pack discharge temperatures are displayed on the ECS synoptic page. The passenger cabin temperature is displayed on the top of the ECS synoptic page. Manual temperature control. If a temperature controller fails and the compartment temperature cannot be automatically maintained at the selected temperature, manual mode should be selected. Pressing in either the left or right manual switch light selects the manual mode for the associated pack. Manual mode indications include: white manual light illuminates in the switch light. Manual mode is displayed on the ECS synoptic page. Cabin or cockpit temperature manual status message. Pack discharge temperature is selected by moving the spring-loaded switch towards the hot or cold position. When selecting either position, the pack discharge temperature is monitored on the ECS synoptic page. Caution! The system does not limit the temperature in manual operation. Consequently, the pilot must exercise caution when in manual mode to prevent overheating or freezing of the pack. Pack over temperature protection. Pack over temperature protection is provided to protect the system against high temperature. Overheat sensors monitor the ACM compressor discharge and duct temperatures. When the temperature at either location exceeds the high temperature trip value, the associated pack valve and the air source bleed air valve are automatically closed to shut down the associated pack. ICAS indications of an over temperature condition include: amber left or right pack high temperature caution message, white left or right pack off status message, white status message associated with the closing of the shutoff valve. Ram air pack cooling. A ram air scoop at the base of the vertical fin is used for cooling of the air conditioning pre-coolers and dual heat exchangers. This cooling is required in flight and on the ground. In flight, ram air is used to cool the high-temperature 10th stage manifold air that flows through both the left and right pack pre-coolers and the heat exchangers. On the ground, each air cycle machine mechanically drives a fan that draws air into the ducting from the ram air scoop. The fans provide the cooling airflow that passes over the pre-coolers and the heat exchangers to affect the heat exchange process. In flight and on the ground, the ram air is ducted overboard through exhaust louvers located on each side of the aft fuselage. Condensation removal. The water separator removes condensation from the conditioned air prior to delivery to the flight deck and passenger cabin. Condensation is collected, then sprayed onto the heat exchangers to improve their efficiency. The water separator is protected automatically against icing by the temperature controller. If icing is detected in the water separator, the pack discharge temperature is automatically increased to melt the ice accumulation. External heating and cooling, optional. On some aircraft, an optional low-pressure adapter allows an external air conditioning cart to be connected to the aircraft. The adapter is installed on the right side of the fuselage. When the external cart is connected, the conditioned low air pressure air bypasses the packs and is discharged directly into the mixing manifold for distribution to the flight deck and passenger cabin.